1. This one is on trinomials with common factors and then also subscripted variables. Okay, so let's talk about what we're doing. So we're doing trinomials with common factors. And here's what it says. They want us to factor something that looks like this. X to the third power plus 6x squared plus 5x. Now, I'm trying to think what lesson this was that we originally started with this. What we're doing is we're going to look and ask ourselves, what does every single one of these nomials, trinomial, because there's 3 of them, 1, 2, 3, what do they all have in common? Well, if you need to extend that to then make this like that, like this, what does all 3 of these have in common?
An X.
An X. Okay, so that's the very first thing, and if you need to do this, you can. Okay, and so if I pull an X out of all of these, then we're going to have an X, and then you're going to create a parentheses problem with this once you've taken out an X. So I'm going to pull an X out of all of them, and you end up getting XX, which is x squared, plus 6x plus 5. Okay? And then the lessons that we've done previously, like yesterday and the day before, we're going to leave this alone, and now you're going to take this problem and you're going to factor it out. Do you remember how we did this? So basically what you're doing is this x, and then you're trying to come up with a number of what times what that will equal 5, but when then added or subtracted would equal 6. Do you remember that? So let's try 5 times 1. Okay? To equal 5 when it's multiplied, but to equal 6 when it's added. So we're going to make a plus and a plus. Let's see if that works. So this just stays here for a minute. I'm just working on this problem. So then let's do it. X times x is x squared, plus x times 1 is 1x. Then let's move to the 5. 5 times x is, everything has a plus in the middle. 5x plus, and then 5 times 1 is 5. Okay? 5x plus 1x are like terms, which equals 6x. That would be like 5 dogs plus 1 dog would equal 6 dogs. Okay? And then it becomes x squared plus 6x plus 5. Does that equal that?
Yes.
Yes. So, we got this correct. Alright? And then you just move your x down. So the final answer for this problem of this is that. Okay, minus all the scribbles and all that. Okay, so it should say x, and then in parentheses x plus 5, and then in parentheses x plus 1. Feel like you got it?
Yeah.
Okay, now, that's the final answer. Alright, let's do a few more. Here we go. Now, it's going to get a little bit harder, so make sure you're paying attention. 4bx3 minus 4bx2 minus 80bx. Now, a good thing to do, just so you know, because we can even factor out or pull out things that are common in between these, is let's go on and make this 2 times 2, bxxx. I'm just making it as extended as it can go. 2 times 2 times bxxx minus, again, 2 times 2, so 2 times 2 bxx minus, and then 80 is going to be a little bit hard, so I'm going to pull it up here for a second. 8 times 10, 5 times 2, 4 times 2, 2 times 2. Okay, so I get 2 times 2 times 2. I'm going a little fast because this should all be normal, something you're used to. That x is right there. I'm sorry, I've got a little bit. There we go. Okay, so then this minus, and then this would become 2 times 2 times 2 times 2 times 5. Okay, bx. Now, what does all of these have in common?
Bx.
Bx, and what other numbers?
2.
2 times 2.
Yeah, 1 for 2.
Okay, this one has 2 times 2, and this has b and an x. 2 times 2, b and an x. 2 times 2, b and an x. Okay, so we can we want to figure that out. What is 2 times 2? 4bx. And if you don't feel comfortable with that, just leave it 2 times 2bx, but this is definitely going to be better for us. So if I take that out of the equation, remember, I'm putting everything else, I'm taking out what's familiar in this, this, and this, and then we're going to come up with an equation. So I've got xx, which is x squared, minus, I'm taking the 2 times 2bx, so then I just have an x, minus 2 times 2b and x. So then I get 2 times 2 is 4, 4 times 5 is 20. 20b, whoops, not bx, because we already took out the bx. You got it? Does that make sense?
Mm-hmm.
If you want to, you can make these plus negative. I'm going to put a 1 with that, plus negative. Okay. Now, you take this, and we're going to factor it out. Okay, so here we go. Same thing we did yesterday in our lessons. So we try to come up with x, and then what times what equals 20. That 5 times 4, I'm going to try it. 5 times 4 would equal 20. And then if I took 5 minus 4, I'd get a 1. So that's good. So now I have to just discover if I'm going to use a plus or a negative, or a plus or a minus. Okay? In order for me to get a negative 20, one of these has to have a negative in front of it. Okay? In order for me to get a negative answer when I add it or subtract it, it needs to be the bigger number. So I'm going to put the minus with the bigger number and the plus there. And that should give us what we want. Let's try. X times x is x squared. X times 4 is 4x. Then this negative 5, I'm going to make that plus negative. Negative 5 times x is negative 5x, plus negative. And then negative 5 times 4 is negative 20. And then when you add our like terms, 4x plus negative 5x, I get a negative 1x. And that does give us exactly what we want. X squared, negative 1x, and negative 20. So we are correct. Alright, and so then, don't forget about this. Just bring your 4bx down to finish it off. Okay, so this is the answer before we factored it, and now this is the final answer. Alright, now really pay attention on this next one because it's a negative number in the beginning, and that's going to become very hard. So, there are 2 ways to do this problem, and I'm going to show you one way first, because this is the way the book decides, or Saxon likes to teach it, or likes the answer to be in this form. So I'll explain that in just a second. So what you're going to do, I'm going to go ahead and make my x's 1x. I'm going to put that 1 back in there. Okay, now what they're wanting you to do is, because this has a negative number in the beginning, what will delete that is to do the opposite. So what we're going to do is, for example, actually we're going to pull it out. So what we're going to do is this negative 1, I'm going to pull it out of this, okay? And this kind of gets confusing, so stay with me. If I pull out a negative here, negative 1 here, then I just have an x squared plus. Alright, if I pull out a negative 1 and it's a positive 1, in order to make this a positive 1, it has to have 2 negatives. So it will become negative 1x, because negative 1x times this negative 1 will become a positive 1x. Do you understand? Just like this x squared times this negative 1 will become negative 1x. Okay, you understand? And then this one would become a negative 20 because negative 1 times negative 20 would give us a positive 20. So basically all we've done is rewritten this, okay, to say something different so that our negative is out of the equation in the beginning. Okay, this is a little bit confusing to me, honestly, but this is the way they want to teach it. So then we take this, leave it, and go on and do our normal factoring out. So x, 5 times 4. What's going to give me a negative answer in my, is going to be one of these negative. And then if I add 5 plus or minus 4, it will give me a 1. And if I'm going to keep a negative, then it has to be this one. Because I need to keep the negative, so it has to be the higher number. And then I just pull this down. But first I'm going to check. X times x is x squared. Plus 4x, I'm going to make this plus negative, and then plus negative 5x plus negative 20. and then this becomes negative 1. So we are right. That's that, yes. So what you do is you just bring this down, and that becomes your answer. Now, originally, when I first did this problem, I want to show you this real quick. Negative 1x squared plus 1x plus 20. I just went on and started off and went, well, if I've got a negative 1x, then I'm going to be 1 to be a positive and 1 to be a negative. Okay? Which when I multiply these together, I would get negative 1 times 1 is negative 1. I would still get the answer. And then I would work it like normal. Okay? But we're not going to worry about doing it like that because that's not the way the book wants it, because here's what they say. It's customary to factor out negative factors so that all the binomials in the factored expression have the form x minus c. So they want it to have x minus c or x plus c, whatever, x plus whatever. So they want you to put it in this form. Okay? So it's very important that you learn how to do this. If you need to go back and watch my video again, then you can. Okay, now this next one is a negative 1, and it's actually a negative problem. And it'll make a little bit more sense with my brain, and maybe it will yours too. So, they tell me to factor this. Okay, again, you can, alright, this is 71.4, and here's the problem, okay? Now, we just did a negative problem, okay, but this is different because this is a negative 3. So we can't do it like we just did the last one by taking the negative 1 out, okay? We're going to have to try to do this in a different way. And so we're going to try to find the common, remember, 3 and how many x's or whatever. So here's what we do. I'm going to go in and break down this. This was a minus 6. I went on and made it a plus negative 6. Okay, so what equals 6? 3 and 2 does. And I'm going to go and bring down my 2 x's. And then x, and I'm going to leave that negative 3 there. Okay? Now, so 3 times 2, I'm going to put times there to show you that. And then plus this 72, when we break that down, it's going to end up being 9 times 8, break that down, 4 times 2. Okay, so then the common, or the factor tree would then look like this, broken down, would be 2 times 2 times 2 times 3 times 3. Now, there we go. So, and then I've got my x up here. Okay, so what does all 3 of these have in common? Well, we see that we have an x in every single one of them. And then we also see that we have a 3. Okay, now stay with me. Can I actually have a negative 3? Well, if I make this a negative 3, the negative 3 times a 2, does that give us a negative 6? Yes. So we can use this negative 3 and this negative 3 to pull out of this. But can we pull it out from here? Well, we definitely have a 3. And if I make this a negative 3, then let's go and figure out what the rest of this is. 3 times 2, 6. 6 times 2 is 12. 12 times 2 is 24. So this actually is really 24 times negative 3. Now, but I want you to see something, because the answer is positive 72. So if I were to take a negative 3 out of this one, this would also have to be a negative 24, because a negative 24 times a negative 3 gives me a positive 72. So I'm going to go in and take out the negative 3's in all 3 of these, and then also an x. Okay? And now we're going to see what our answer is. So if I pull out a negative 3x from every single one of those, what do I have left? I have xx, which is x squared, plus, if I took out the negative 3 and an x, then I have a 2x, plus I have this all equals negative 24, and if I took out the negative 3 and x, then I would just have a negative 24. Okay, so that becomes our new problem. And then I'm going to take this and go in and factor it out. So x times x, and then we're going to ask ourselves, what times what equals 24? But then if we minus them or added them, will equal 2. Or 6 and 4 come to my mind. Okay? And so I ask myself, if I multiply 6 times 4, I get 24. But I need a negative 24. So one of these, either the 6 or the 4, is going to be negative. Okay, so I asked myself, if I subtract 6 and 4, then I need the negative here because I don't want to take the higher, or I want to take the higher number's positive value, since this is a positive 2. So 6, and then the negative 4, when you subtract those, will give us a positive 2. So we got that right. And then 6 times negative 4 will give me a negative 24. So we got it right. And so all this is correct, and then we just bring down the negative 3x. And that completes that one. Alright, now the next portion of this math lesson is on subscripted variables. Okay? And what a subscripted variable it looks like is this. Okay? It's got like this 5n and then a subscript n. Plus 10n with a subscript d. This would be something like, I have 10 numbers of nets, and I have 5 numbers of nets plus 10 numbers of dogs. That's kind of what they're saying. So when I look at this, this is kind of confusing to my brain. So what I end up doing is just going 5, and what makes this different is an n, plus 10, what makes this one different is a d. That makes more sense in my brain. And then at the very end, I can write it in the form that they want to keep it in. And if you want to just leave it, you can even put an x and a y. I don't care. But when you answer the final answer, go on and change your NN and your ND back into those answers. Okay, so let's go on and do one of these problems. Okay, and we're supposed to be using elimination. Now, there's going to be there's going to be two types. You're either going to eliminate or you're going to substitute. Those are the two things they're going to try to teach you to do, or you've actually learned it before. But they're actually going to start saying eliminate or substitute, and you're going to need to know what to do. So, for example, we have 5n with a subscript n plus 10n with a subscript d equals 125. Okay? And then they have n plus nd equals 16. Now, okay, I wanted to share something with you real quick before we move on to this next problem. We're moving into something called subscripted values. Okay? Now, when you look at this, this may look confusing because what we're used to working with, let's show you down here. We're used to working with something like 5n plus 10d equals 125. Okay? Or, so this would be like 5 nickels plus 10 dimes equals what? Or 125 or whatever. And you have to figure out how many dimes and how many nickels. Something like that. But they're showing you the NN, and that just means the number of nickels, the number of dimes, so to speak. Okay, so when you see this NN or this ND, don't flip out, just see it as one letter. And then you can even write it as one letter. N, you could just change to an N, and then ND, you could just change to D. But when you write your answer, you're going to have to write the answer of what is the answer to NN and what is the answer to ND, and not just D's answer and N's answer. So it's important that you learn to see it like this, but don't get flipped out about it. Just kind of see it as one letter. That's what we're used to working with. So that kind of explains what subscripted values means. If you remember elimination, what that means is we're going to take and try to come up with and eliminate one of these letters, either the NNs or the NDs. And if you remember from previous lessons, I'm going to go on and multiply this one by -5. And when I do that, this becomes -5NN plus a -5ND equals, what's 16 times -5? -80. Okay? So then, if you remember the elimination method from here, look right here, we have a 5NN and a -5NN. And guess what? Those cancel each other out. Remember this?
Yeah.
And then I just go 10 plus a -5 would give me 5ND. And then 125 minus 80 is going to equal 45. Okay? And so then it says 5 times what equals 45? We know that ND equals 9. Okay? So then, once I've got my answer ND, I'm going to put that over here, ND equals 9, then what you do is you go in and take and look at the next, where it said 5NN plus 10ND equals 125, and then it says NN plus ND equals 16. Now you can just take this ND, put it into that spot, 9. Now it asks, what plus 9 equals 16? And we know that NN is 7. Okay? So 7 plus 9 equals 16. So we know that ND is 9 and NN is 7. Okay? Don't get confused at double letters. That's just called subscript. This little letter right here is called a subscript. Okay? Alright, so that's elimination. And now let's look at substitution. Alright? An example of the substitution would be like this. It says use substitution to solve. And then it's got 5n subscript little n plus 25 in subscript q equals 290. And then underneath that it says this, nq equals n plus 2. Well, that's pretty easy because it already tells us what NQ's answer is. You see that? NQ equals this. So because NQ equals this, we're going to go up to NQ and insert that. See what I'm doing?
Yeah.
Okay, so now I'm going to pull this down here, and it's going to be 5n plus 25 n plus 2 equals 290. So all I've done is this had NQ here, but NQ is this, so I'm inserting it in that. Okay, and now I'm going to go on and multiply this part. 25 times NN becomes 25n plus 25 times 2 is 50. And I'm going to bring everything else down. Alright, and now I'm going to add my like terms. 5n plus 25n becomes 30 n. Okay? And then this is a number and a number, so I'm going to move this positive 50 over here. And it becomes negative or minus 50. So it's going to become 240. Got it? And now this is saying 30 times what equals 240? And the answer would be 8. N equals 8. Am I right? Yes, I am. So if N equals 8, N equals 8, then what you can do is look up here, and if we put 8 where N is, then what does NQ equal? 8 plus 2, NQ equals 10. And that becomes our answers. You got it? Alright, that is lesson 71.